in this last video about basic distribution, you can see that the problems we're tackling, which are numbers 9 through 12, don't look like they have a number in front of the parentheses. They have a negative sign, and that's it. Now, that's kind of a trick. There is, in fact, a number invisibly sitting in front of those parentheses, between the negative sign and the parenthesis. But because it's invisible, it has to be a number that, when you're multiplying, doesn't change the numerical value of something. And if you think about it, there is a single number that when you multiply by it, it doesn't actually do anything. If you think about it for a second, the number that I'm talking about is 1. And at least for now, as we're, delving into distribution and maybe not super familiar with it, it's probably to our benefit anytime we see a minus sign and then an opening parenthesis, and we see addition or subtraction inside that parenthesis, so we're seeing distribution. It's probably worth our time to quickly rewrite the problem and make that currently invisible one visible. Because if we do that, now we know clearly we are giving a -1 with multiplication to both this -4 and this positive 9x. So we have -1 times -4, and we have -1 times 9x. The first half of the problem, we have negative times negative, so we have positive, and 1 times 4 is 4. On the back half of the problem, we have -1 times positive 9x, so that means we will have negative, and 1 times 9x is 9x. In number 10, if I take a moment to rewrite the problem and make the invisible one visible, we get -1 times the quantity x minus 5. When we expand this, we get -1 times x plus -1 times -5. -1 times x is -1x. On the back half, -1 times -5, we have a double negative, which means we have a positive product. 1 times 5 is 5. Now, just a special note here. Just like the 1 is invisible to start this problem, when there is a 1, whether it be positive or negative, in front of a variable, we don't, strictly speaking, have to make it visible. -1x plus 5 and -x plus 5 are the exact same statement. There may come a time where you could be penalized for writing the 1, depending on how far you study mathematics. Just some teachers, some college professors would deduct points because of the redundancy in writing the 1. It's understood to be there. That would not be something I will do to you this year. If you write 1x or -1x, you will get full credit. Number 11, again, I'm going to take a moment to rewrite it as -1 times the quantity p minus 8, just making that invisible 1 visible. And then I can expand this. So I've got -1 times p plus -1 times -8. -1 times p is -p. On the back half, -1 times -8 is positive 8. And as with number 10, we can write this as, back in the original problem I should have put the -1p, which can be written as -p plus 8. Making my -1 visible in number 12 lets me see the expansion of -1 times x plus -1 times -4. -1 times x is -1x. -1 times -4 is positive 4. And again, that can just be written as -x plus 4. Now, something the eagle-eyed amongst you may have spotted In number 9, inside the parentheses, we have negative 4 and positive 9x. And our answer is positive 4 minus 9x. They've changed sign. In number 10, inside the parentheses, we have a positive x and a negative 5, but our answer has a negative x and a positive 5. And this pattern continues in 11 and 12. For those of you that are comfortable with your negatives, the statement that distributing a negative sign only changes the sign of everybody in the parentheses is going to make a lot of sense. And if that makes sense to you, and you understand that, and you feel you can jump straight to the answer on these types of problems, you have my blessing to do so. But if that confuses you at all, you can see how I made the invisible one visible and then continued to use the expansions that we've been using for the last several days. And that is absolutely a tool that if you need to use, I encourage you to continue using.